we saved the best speaker for the last. It is my pleasure to introduce Dr. Julie Devallière from Curadigm, and she will talk about Nanoprimer technology.
So good afternoon, and thank you for inviting me to this session and giving me the opportunity to present the technology we develop at Curadigm, which is a French biotech company. And we believe, and hopefully I will convince you, that our technology can change the treatment paradigm, especially for nanomedicine, by redefining therapeutic bioavailability and toxicity. So as you all know, one main challenge of IV-injected nanomedicine is the low delivery to the target site, which is due to accumulation of the nanoparticles in the phagocytic cells of the liver and spleen. So, as shown here, following an intravenous injection, 5 minutes after that, the nanoparticles, almost all of them are trapped by the liver and very few are circulating, which means only a small percentage of therapeutic reaches the target tissue, and that decreases dramatically the efficacy and safety of the nanomedicine. So to address this issue, at Curadigm, we develop a liposome that we call the Nanoprimer, and the role of the Nanoprimer is to turn off the liver to prevent therapeutic clearance. So how it works, first the Nanoprimer is IV injected. So we said that we prime with the Nanoprimer, we prime the body to receive the treatment. So the Nanoprimer accumulates specifically and efficiently in the liver and blocks the liver pathway involved in clearance. So in the second time, you can treat with the therapeutics, so the nanomedicine, and the nanomedicine can circulate much better, much longer, and accumulates also more efficiently in its target. So that could be a tumor if we're talking about oncology. And when the Nanoprimer is cleared, the therapeutic and metabolized, the therapeutic clearance resume. So you can see on the bottom panels of that's the same nanoparticle injected, but this time we prime with the Nanoprimer the mouse, and we obtain this extended nanoparticle circulation time. So we increase bioavailability to boost accumulation in target tissues. So that's the main characteristic of the Nanoprimer. So as I said, again, its role is to increase blood bioavailability, to increase accumulation in the organ, and to increase efficacy. We know that the Nanoprimer is safe, it's biodegradable, it's lipid-based, and it can decrease also potential hepatotoxicity of the nanomedicine. Regarding the mode of action, the Nanoprimer occupies clearance pathway in a highly specific way, and it's only due to physicochemical properties. There is no API. And you don't need to modify your therapeutic to use the Nanoprimer. So that's all the data we collected to show that the Nanoprimer is safe, and all the in vitro results were also confirmed by NCL evaluation. So we showed that the Nanoprimer is not toxic on macrophages, on Kupffer cells. It does not induce hemolysis or impact on coagulation. It does not induce activation of the complement system, and it does not induce cytokine-mediated immune reaction. Regarding in vivo data, it's the same. In mice, we have seen no sign of toxicity, even with a maximized dose of the Nanoprimer. Regarding the mode of action, we know that the Nanoprimer decreases nanomedicine uptake by Kupffer cells, but also by liver, sinusoidal endothelial cells, and hepatocytes. And it's mainly, but not only, through the interaction with the scavenger receptor type A. So since the Nanoprimer can improve the delivery of different classes of nanomedicine, we did also different proof of concept with external partner. And here it's a proof of concept with the Antapodia company. They are developing siRNA LNP that has anti-tumor properties. And they did a triple-negative breast cancer tumor model. And they showed that the Nanoprimer significantly improves anti-tumor efficacy of their siRNA LNP with a tumor growth inhibition that is about 36% with the LNP alone. So that's the orange line. And this TGI goes to 85% when the Nanoprimer was first injected before this LNP. And the LNPs are injected at the same dose for both. So you can see that the nanoprimer improves the efficacy of siRNA-loaded LNP. We have also shown that the nanoprimer improves the efficacy of small molecule-loaded nanomedicine. So for that, we use Onivyde, which is a liposomal form of irinotecan, so chemotherapy. We did a colorectal cancer model, and we follow tumor progression. So the red line shows the tumor size of mice treated with Onivyde alone versus the blue line that is mice treated with nanoprimer plus Onivyde, again at the same dose. And you can see the difference in tumor cell proliferation and the increase in the efficacy of Onivyde. And this result was correlated with the fourfold increase of irinotecan, so the drug encapsulated in Onivyde. So a fourfold increase of the level in the tumor thanks to the nanoprimer. We did other studies with external partners that showed also the ability of nanoprimer to improve efficacy of carriers such as polymers and cholesterol conjugates. Another interesting delivery system is the virus, so the viral vector. And we were curious to see if the nanoprimer could also enhance delivery of virus. For that, we did another collaboration with a company developing an oncolytic virus. So we did a biodistribution of this virus with or without the nanoprimer. And we showed that the nanoprimer increases by more than tenfold the number of viral copies in the tumor. And after 48 hours, the number of viral copies in other organs, such as liver, lungs, and spleen, were close to zero. So the nanoprimer increases drastically the delivery of oncolytic virus in the tumor without introducing additional toxicities. And finally, we wanted to show you this nice study performed by NCL in collaboration with the NCL. So this study is to evaluate the nanoprimer impact on vaccine immunogenicity using a gold nanoparticle valbumin model. So for that, 5 males and 5 females mice were treated. So they were IV injected with gold nanoparticle valbumin alone or following nanoprimer treatment. And then blood was collected over time, and anti-OVA IgG and IgM were quantified. So as you can see, with the gold nanoparticle valbumin alone, there were no production of IgM. So all the gold nanoparticles were taken up by a phagocytic cell. But with nanoprimer administration before immunization, we obtain a dramatic increase in anti-OVA antibody levels. So IgM appears as expected on day 7 and remain elevated until day 20th. So that shows a sustained immune response. Regarding IgG, it's the same. We obtain a tenfold increase of the level of IgG when the nanoprimer was first administered before immunization. And IgG as seen as early as 7 days. So we obtain a robust and sustainable immune response. So the nanoprimer leads to the saturation of phagocytic cells so that the gold nanoparticle of albumin can have access and can be delivered more efficiently to antigen-presenting cells. So the nanoprimer show also great promise for cancer vaccine by IV route. So I show you that the nanoprimer is safe and brings significant benefits to multiple nanomedicine classes. So from encapsulated small molecule to a nucleic acid and virus. And also it can be used for several indications. For oncology, for genetic disease, but also for vaccine, with potentially other administration route that could be tested. So I'd like to thank all the Cura team, so all the team at Curadigm that works on this project, as well as our collaborator, Kelvin Tsai from Antapodia, and the NCL and Marina and all the team of Marina that did this nice study with the vaccine. Thank you for your attention.
Thank you very much. You stay here.